Good morning. This is Mr. Precella with this college algebra class. We're reviewing for the final. We're going to pick up where we left off on the last video at number 16, domains of functions. Notice it says to find the domain, and it gives us two different functions. I have those. I'm a big writer, so I have the functions written down here. And first of all, f of x equals x divided by the square root of x minus 4. To find domains of expressions containing square roots, remember what do we not want to happen with the square root? A negative underneath there. You want to avoid, when you're dealing with square roots, you want to avoid the square root of a negative number. So what I do, I look at the radicand. Whatever that radicand is, I ask myself, when does that equal 0? And that's when x is equal to 4. So I then draw a number line and I look at what's happening on either side of 4. Under most circumstances, you expect one side of 4 to give you imaginary numbers, the other side to give you numbers that are not imaginary. So to make a decision, we take something like, let's see, a number to the left of 4, maybe a 3. If we tried to use 3 for x, could we get a y value back? If we plugged in 3 into the function, we'd get a 3 over the square root of 3 minus 4 is negative 1. Is that a real number? No, that negative there says this is imaginary. So we do not want that side there. So I imagine the other side will give us y values that are not imaginary, but to verify that, we could use a number like a 5, any number bigger than 4. We could use 5. That would give us a 5 over. What are we going to get if we try to create a y value by plugging in 5? That's the square root of 1, a square root of positive 1. That is not imaginary. That is not imaginary. So this is the side we want. This is the side we want. All that's left to decide is it okay to use 4 as a y coordinate? Can 4 be a y coordinate? If you take 4 and plug it in, if you plug in 4 for x, you'll get a 4 over 0. The square root of 0 is 0. Is that a real number? 4 divided by 0? Not a real number. So how are we going to label 4? Open or closed? Open. You don't want to shade in 4. So our domain is all numbers to the right of 4 on the number line. How would we say that using interval notation? Comma, infinity. Parentheses 4 comma infinity. So looking at number 16, 4 comma infinity, where are we? Right here. There it is, response B. Number 16 will do the same thing. I see it's another problem involving a square root. So I ask myself, when is the radicand equal to 0? When does 6 minus x equal 0? Moving the x over to the right, we get when x is equal to 6. So there's 6. We expect one side of 6. We expect one side of 6 in most cases. One side will give us imaginary numbers. The other side will give us real numbers. So choosing the numbers to the left of 6, maybe 5. If we plug in 5 for x, can we get a y value back? A number that can be labeled on the y-axis. That gives us a 6 minus 5. That's a positive 1. That's not imaginary. So this side's acceptable. But what's going to happen to the right of 6? Say if we use 7. We'll get an imaginary, and you can test that and see for yourself. 6 minus 7, that gives us the square root of -1, and that is imaginary. So that we don't want that side. All that's left to decide is 6 okay as a x value? If you plug in 6 for x, do you get a number back, a y value back that you can label on the y-axis? So if x is 6, you'll have y equals the square root of 6 minus 6. That's a square root of 0, which is 0. That's a real number. So how are we going to label 6? Closed circle. So how do we say that shaded interval using interval notation? Parentheses, I heard it. Negative infinity. 6 bracket. We're including the endpoint 6 for my final answer. And looking back at number 17, let's see. Negative infinity up to 6 bracket. That looks like response C. Well, what was the difference? In 16, we didn't include the endpoint. Notice we put a parenthesis. In 17, we did include the endpoint. What was the difference? Both of them involve square roots of 0, but...
For number 16, you can't divide by 0.
Okay, number 16, you can't divide by 0. Okay, so we cannot include the cut point. Number 17, there's no denominator there. You're not dividing by 0, so you can include that cut point of 6. Any questions? Okay. Number 18. It is a piecewise function. They want us to draw the graph, and I've rewritten this. Hold on. There. I've rewritten this right here. Here's the function that we're going to be graphing. To graph piecewise functions, I would just make a table of values for each piece. We're plotting points, but we're plotting points intelligently. We're not just randomly choosing, plug in 1,000, plug in -1/3. We're plotting the points intelligently. So we have 2 pieces, piece 1 and piece 2. I'll make 2 tables. The first table is the purple table. What's the first number I have to use for x?
1.
I have to use the number that appears, or any number that appears in the inequality. If there had been a compound inequality, we'd have to use both of those numbers. But as it is, the only number appearing within the inequality is a 1. Now 1 is a cut point. It appeared in the inequality. Sometimes we label cut points with open circles. Will this cut point be labeled with an open circle?
No.
No, because there is the possibility of equality here. We need another x value. Could I use 0? No, I have to choose an x value bigger than 1. 2. Okay. Now, regardless of the x value, what's the y value going to be? 3. There's no x's to plug in. Now, the second piece. I'll make the 2 tables, then I'll draw the graph. What's the first number I need to plug in for x? 1. That's a cut point. Will that cut point be labeled open?
Yes.
Yes, because there's no equality. I need another x value, one that's less than 1. What do you think I'll use? 0. Plugging in 1 into the red piece, what are we going to get? -4 minus 1, I agree with -5. Plugging in 0, what are we going to get? -4. Hey, is this point here going to be an open circle, 0, -4? Is 0 a cut point? Did it appear in the inequality? So any point that you choose yourself is just going to be a regular closed dot. The only time when I wrote this problem down, I knew I could have at most one ordered pair that's opened. It would occur when I used 1 in the red piece, and that's the one open circle that I have. I'll draw my XY grid. Drawing my XY grid. So the purple piece. Write 1 up 3, close dot. Write 2 up 3. And that's the number. I'm going to label that cut point of 1 on the x-axis. X greater than 1. It starts here at 1. It goes to the right. Does it stop? Does this interval x greater than 1? No, it keeps going to the right. So the graph keeps going to the right. Now the red piece. 1, -5, 0, -4, x less than 1. That interval on the x-axis starts at 1 and goes to the left. Does it stop? No, so the left side shouldn't stop. There. So notice we have on the horizontal ray we have a closed dot at the end point. On the diagonal ray we have an open circle at the end point. So let's look and see which graph matches the one we just drew. So A, B, C, or D? D, I agree. Notice the closed dot and the open dot. I'm going to agree with response D. Any questions there?
I thought that was open.
You thought what was open?
The
-4 and 0.
The -4, 0?
Or 0, -4.
No, is 0 a cut point?
No. The 1, -5.
Do you have the review sheet printed out? You're just
No,
not
I don't.
seeing the open dot there and the closed dot.
Okay.
When I'm looking at the paper version, there's clearly an open dot there. It's just that projector there that you're not seeing it. And it does look closed. You're right about that. But that is clearly an open dot. Does anyone else have it printed out? Yes, it's clearly an open dot. Okay. So that is clearly there, an open dot. Is that better? Yes, okay. Number 19. Find the domain of f divided by g when f of x is equal to 2x minus 6 and g of x is equal to 9x minus 2. Now, if we're going to find the domain of f divided by g, we better find f divided by g. So, here we are at number 19. Before we find the domain of f divided by g, let's determine what f divided by g is. The quotient of two functions. Could it be easier? You just take the first f of x and divide it by g of x. F of x and g of x are linear functions. The graphs would both be slanted lines. The ranges and domains are both the set of all real numbers. But that's not the domain of this quotient here. Something happens here that we don't want it to happen. That we don't want to happen. What could happen here with this quotient?
It can equal 0.
Where? The denominator, we do not want the denominator to equal 0. So 9x minus 2 should not equal 0. That means 9x shouldn't equal 2, so x shouldn't equal 2/9. So x can equal anything except 2/9. How do we say that using interval notation? That x can be any number except for 2/9. If you think of a number line, here's the number line. X can't be 2/9, so 2/9 isn't shaded.
-170.
But
Equals 2 9.
okay, negative infinity to 2 ninths.
Parentheses, union.
Negative infinity to 2 ninths, and what went in front of the negative infinity? Parentheses, and after you said parentheses, union.
And then parentheses 2 9. To infinity.
To infinity. This interval is saying all the numbers to the left of 2 ninths. This is saying all the numbers to the right of 2 ninths. And personally, I'd rather my math lab and the test generator wrote it out in words, but they're not inclined to do that. They're using interval notation, A, B, C, or D. C. And notice if you get confused and start thinking it's the numerator that can't equal 0, then you're going to incorrectly choose response D. A numerator can be anything. Remember, when we're dealing with fractions, it is a number divided by 0 that says, no, you cannot do that. That is undefined. Number 20. They give us a function. They ask us to compute and simplify the difference quotient, f of x plus h minus f of x all divided by h. Remember when we were simplifying these in class, I would break the process into 3 steps. So that's what I'm going to do. I'm going to use the 3 steps. The first thing I'll do is just evaluate f of x plus h. For polynomial functions, that's the long part. Then I'll subtract off the original function f of x. The third step will be to perform the division by h. So the first thing I'll do, let me move this down there. So the first thing I'll do is I'm going to find f of x plus h. What is that telling me to do, f of x plus h?
Plug x plus h every time you see
Plug in x plus h every time you see
an x.
an x. Well said. And that x plus h squared is not just x squared plus h squared. What would we do then? If you know the perfect square formula for doing it in your head, then great. But if you don't, or if you've forgotten that, what would we do to square x plus h? Write 2 of them side by side and FOIL it out. Yes. So I think I'll do it on my scratch paper. My scratch paper's right here. X plus h times x plus h. First, outer. Well, it's an xh and an hx. Generally, if I have this 2 different letters in the same term, I write them alphabetically. So x times h, I'll write as an hx, and then another hx, last h squared. So that's where you got the x squared plus 2hx plus h squared. And suppose we had an x plus h cubed. Suppose that had been a 3x cubed. Well, before the binomial expansion that we saw in our last homework assignment, we would have had to write it twice and keep going. But now with the binomial expansion, I can do that in my head and get what? An x cubed plus 3x squared h plus 3xh squared plus h cubed. So that's where the binomial expansion would come into play if you had a binomial being cubed. You could use Pascal's triangle to get the coefficients, and it falls out very quickly. So anyway, we have a 3. That x plus h squared, that's that green stuff, x squared plus 2hx plus h squared. And I still have that minus 5 times x plus h. Now, all in one step, I'll go through and distribute the 3, distribute the negative 5. That's going to give me, when I go through removing those parentheses, 3x squared, keep going, plus 6hx plus 3h squared plus Oh, it is a plus. Thank you. That is a plus. So plus 5x plus 5h. Okay. That was a plus. And notice there are no like terms to combine. So we're through with that first step that I would do. The first thing I do is simplify f of x plus h. The second step, I'll do my little second step in red. I'd take what I just found and I'd subtract off the original terms. I'd take what I just found, f of x plus h, and take away the original terms. So I'm taking what I just found and I'm subtracting off a 3x squared and I'm subtracting off a 5x. What am I going to have left?
6hx plus 3h squared plus 5h.
Right. Every term that's left, when you're dealing with the difference quotient of any polynomial function, even that hypothetical one with the cube, an x cube instead of an x squared, any polynomial function, when you're finding the difference quotient in this step, the only terms remaining will contain which letter? H. Anything that doesn't have an H is going to subtract off if you're doing this correctly. The third step, I then divide by H. That's what they were actually asking for here. So I'm taking what I just found in step 2 and I'm dividing it by H. What I would do, remember I said every term in the numerator would have an H. I'd factor out an H. What am I going to have left in those parentheses?
6x plus 3h
Plus 5. Cancel the H's to give me 6x plus 3h plus 5 for my final answer. Any questions there? Even though they wouldn't ask us to break this into 3 steps, they just say find the difference quotient, I'd break the process into 3 steps. I find f of x plus h first. That's usually the longest step. Then I subtract off the terms from the original function. What do they have in common? You take away the 3x squared, you take away the 5x. And then the last step, I divide by h. And since every term in the numerator has an h in it, you can factor out the h and cancel. Oh, let's pick out the correct response. 5x plus 3h plus 5, no, 6x plus 3h plus 5. That looks like response A. And number 21, find the requested function value. They want us to find g composed with f of 40 when f of x is equal to x minus 4 over 6 and g of x is equal to 4x plus 6. So, moving on, number 21. Let's see. Oh, I've even written down what I want to find there. Okay. First thing I would do is I'd write that f composed with g, that fog notation. I'd write that as f composed with g of x. That means f is on the outside.
Yeah.
Oh, did I miscopy the problem? Yeah, and you know something? If I'd worked this problem out, I bet you anything the answer I get would be one of those numbers right there. So I'm looking, y'all can't see what I'm looking at. I'm betting anything if I'd found f composed with g, it would have been one of those answers. So make a note, I miscopied the problem. I suppose I should stop the video, but I figure, no, why bother? So, but thanks for pointing that out. That means which function's on the outside? Okay, in the error that I was writing, f composed with g, f was the outer function, but we want to find g composed with f. That means g is the outer function. So g composed with f of 40 That means G is on the outside and f of 40 is on the inside. So f of 40. First thing we should do is find f of 40. What's that saying to do? Okay, so we're going to f. We're going to plug 40 in for x. So we come up here to f. 40 minus 4 is 36 divided by 6. What's f of 40 going to reduce to? Just 6. So now we have g of 6. What's that saying to do? So we go to g, we plug in 6 for x. So we come up here. 4 times 6 plus 6, that gives me what, a 30 for my final answer. 30 for my final answer of A. Any questions there? And number 21, I better look and make sure that I wrote down the correct problem. Okay, so f of x is 7x minus 6. G of x is 5x squared minus 7x minus 6. They want me to find f composed with g. It looks like I wrote that one down correctly. So f composed with the g of 3. F composed with the g of 3. What's my outer function? F is on the outside. What's on the inside? G of 3. And what's G of 3? What's that saying to do? So we go over and plug in 3 for G. Plugging in 3 for G. We go to G, here's my scratch work, we're plugging in a 3. That's going to be a 45 minus 21. The 45 minus a 21, is that a 24 minus a 6? That's giving me an 18. So I have f of 18. What's that saying to do? So we go to F, we plug in 18, and 7 times 18, is that a 105 minus a 6? I'm getting a 99 with my 126. 126 minus 6, so just a 120. Okay. Let's see. Yeah, you're right. 8 times 7 is not 32. Is it okay? So where is it? Looks like response D. Oh, and a word of warning. Let me see something. Give me a moment to check something. I'm curious. Earlier on number 21, the way I was accidentally finding f composed with the g of 40. If I'd used if I'd found f composed with the g of 40, if I'd reversed what I was doing, that would have been a 166 minus. Okay, if I'd accidentally found f composed with g of 40, I would have gotten a 27 for the final answer. So if you accidentally find the composition the wrong direction, one of the distractors will be that reversed order, so be careful. Be sure to find the composition that they're asking for. And 23, let's see what we have here. For the given functions f and g, find the indicated composition. Well, I think we'll take a break right now, okay? So let's just take ourselves a break for a few minutes. Bye-bye.